Good everybody, so welcome to Noble Team YouTube channel, and my name is Noble, CEO and founder of Noble Team, and we are going to be looking into physics for today's class. And the topic we are going to be looking into is a vital topic that students find it difficult to do what? To know. So in this video, I'm going to be explaining every single thing, every single aspect, every single calculations, because basically in this video, we are going to be looking into calculations. So the theoretical part, we are not going to be looking into it. Is the calculation aspect of radioactivity that we are going to be looking into. And if you are not subscribed to this our channel, do well to subscribe, like, and share, okay? And make sure you are with either your headphone, your earpiece, or your headset, because it's going to limit distraction, because you don't need distraction, because we are about to dissect radioactivity. Okay, now looking at the board, we have important formulas you need to take note on that radioactivity. And see, once you take note of all these formulas, okay, once you take note of these four formulas that is on the board, is it for yes? Once you take note of these four formulas that is on the board, you are good to go under radioactivity. Okay, so we have the first formula, we have the second formula. This second formula is being used when you have been asked to calculate for the fraction remaining after decay. You are going to be solving up to 10 solid questions, and it's going to be covering every aspect of these formulas. And trust me, up to 1 to 10. Trust me, you are going to do what? Know how to solve any question that comes in one radioactivity. Okay, now you use this formula when you are being asked to calculate for the fraction remaining after decay. So we use this formula when you are being asked to calculate for the fraction loss of the decayed after decay. We now use this formula to calculate for the decay constant. When you press link 2 in your calculator, it's going to give you 0.693. Okay, so now before we start, I want us to take note of something. Okay, we have n here. Okay, n is the quantity of, okay, let me put it this way. Okay, n is the quantity remaining after decay. Okay, n is the quantity, which is this n now. N is the quantity remaining after decay. Okay, now when you talk about this n degree, okay, when you talk about this n degree, it's talking about the initial quantity before decay. Okay, now which one again? We have our T, our big T. Okay, our big T is our half-life. This is also a half-life. Okay, now our T is the time taken to decay. Do you understand? Our T is the time taken to decay, and our N is the number of half-life. So I've given you the parameters of what you need to know, and let's start by solving questions. Okay, let me get my phone. So all I implore you to do is make sure you follow this video to the end. Avoid distraction. Okay, now the question will appear on your screen, and do well to do what? Do well to follow intensively, do your calculations, punch your calculator when I'm punching, because I might not be correct. You correct me in the comment box. Okay, so now let's start by solving question 1. Okay, let's start by solving question 1. Now the question will be on your screen. They said the half-life of a radioactive material is 12 days. Then calculate the decay constant. Calculate the decay constant. Okay, question 1. We have been asked to calculate for the decay constant. We are using this formula where we have that was 0.693 divided by half-life. So our half-life here is what? 12. Now punch your calculator and tell me the final answer fast. Okay, punch. Let me look for my own calculator. So we have 0.69. This phone. So we have 0.693 divided by what? By 12. So I have it to be what? 0.05775. And this is our final answer. Okay, now let's look into the question to know which option is correct. We have option B to be correct. So this is it, and we are done solving this. Okay, now the next one is question 2. Listen attentively, we are just starting. Okay, so question 2, they said the half-life of a radioactive element is 9. The half-life of a radioactive element is 9. what fraction of atoms has decayed in 36 days? They said what fraction have decayed in 36 days. So we are using this formula. We are being asked to get the decay, the fraction loss, or the decayed after decayed. Okay, now this is the formula we are going to be using now. Is either we use this or use this. So we don't have the initial. Okay, we don't have the initial, but this we are going to be using this because we say that n is what? For us to get our n, you can either use this or this. They are still the same thing. Okay, so now let's move. Using this formula, which is FR. Make sure you are paying maximum attention. FR 1 minus what? I'm going to show you something here. N. Okay? Now we have been asked to get our FR. So FR is now equal to 1 minus 1 over 2. Since N is equal to T over 2. Okay? So our time here is what? They said has decayed in 36 days. So it's going to be what? 36 divided by our half-life is what? 9 days. Okay, so what again? We have FR. Punch your calculator fast. So 36 divided by 9, 36 divided by 9, we have it to be 4. Okay, we have it to be 4. So basically we now have, let me finish it here. Okay, so we have 1 minus bracket 1 over 2 raised to power 4. And for us to now open this, we can now have FR is equal to 1 minus 1 raised to power 4 is what? 1 raised to power 4 is like saying 1 times 1 times 1, which is what? Which is 4 over 2 times 2 raised to power 4 is like saying 2 times 2 times 2 times 2, which is 2 times 2 is 4, 4 times 2 is 8, which is what? 16. No, this one, okay? This one, and this what? 16. Now, what is the next step to take? So we are not done, no? We are not done yet. So this is it. It's like finding the LCM of it, which is 1 over 16. Okay? Now the LCM of this is what? 16. And 1 divided by 16 divided by 1 is what? 1. Then 16 times 1 is what? 16. Minus 16 divided by 16, 1. 1 times 1 is what? 1. So when you do your normal substitution, you now have it that FR is equal to what? This is 15 over 16. So your final answer is what? 15 over 16. And you are done. So looking at the option, we have it that option D is correct. Okay? So I hope you're understanding. So let's move. Now this one is quite different. Okay? It's quite different. They now said, you see the question on your screen. They said when you see the question on your screen that lead has a mass number of 210 and a proton number of 82, decays to what? 206 mass number and 80 proton number, then what do it emit? Okay, what does it emit? Now I want you to take note of something. That let me use blue marker because this is part of calculation aspect. Okay, this is part of calculation aspect, excuse me. So now moving on, when you see helium atom, you are talking about what? Alpha. Okay, when you see electron, you see 0, you see -1. They are talking about beta. All right, now looking at this, okay, they say that when 210 decays to this, so what particle does it emit? Now question 3, right? So it's like saying, okay, he said that now this is it. He said that okay, it was initially what? PB, which is what? 210 and 82, and it now emits what? It emitted 206, then PB and 80. Now what is remaining? Okay, now when you subtract 210 minus this, what are you going to be having? 4. And when you subtract 82 from this, what are you going to be having? 2. So we are having what? Alpha particle. Okay, so looking at the option D is correct. Alpha particle. Okay, look at the board. Helium, its max number is 4, its proton number is 2. Now when you hear helium, they are talking only about alpha particle. when you see this, they are talking about beta particle. Okay, now let's move on. So when you talk about the next one is question 3. So I hope you understand. Now question 4. Okay, now let's talk about question 4. They say that during the nuclear reaction described by this, let me write out that equation. So we have 235, then W, we have 92, and this. So we have 235, we have W, and we have 93. Okay, then we now have another one, 2. Okay, this is X. Okay, this is X. So you see the question on your screen, 231, and we now have 91. This is Y. They now says the particles emitted are respectively what? Now, this was the initial one, okay? And we need to get X and Y. So now pay maximum attention here. 35 minus 35 is going to give us what? 0. We write out 0. Pay maximum attention. We write out 0. Okay? Now, still moving on. 92 minus 93 is going to give us what? Minus 1. And this is what? Electron. And electron is leading you to what? Beta particle. So we are going for beta. Now, 35 minus 231 is going to give us what? 4. Now, 93 minus 91 is going to give us 2. So the first one is what? Beta particle. The second one is what? Alpha particle. And looking at the option, let's analyze the option. We have option A, beta particle and alpha particle, beta, which is beta B, alpha beta, D, alpha. So option what is correct? Option A is correct, beta alpha. Okay, now let's solve question 5. I'll tell you that radioactivity is very simple. We are just starting. Okay, we are just starting. Okay, now let's solve. They said after 3 half-life, the function of a radioactive material that has decayed is what? We have been asked to get what? The function of a radioactive material that has decayed. They said after 3 half-life. Okay, what formula are we going to be using? This. Okay, we have been asked to get what? The function of a radioactive material that have decayed. This question 5. Now using this formula, we have, do we have half-life? We said after 3 half-life. Okay, where is it? After 3 half-life, the function that have decayed. So our 1 minus 1 over 2, okay, into brackets. So now we have half-life already. So no need of us looking for the number of half-life. So our number of half-life here is what? 3. Okay? Our number of half-life here is what? 3. So doing our normal substitution, we can now say that 1 minus 1 over what? Over 6. Do you understand? So I'm looking for the LCM of this. Like saying this is 6 and 1 is here. It's still giving us, because this is going to be 1, it's going to give us 6. Okay? Then minus, this is going to give us 1, which is what? 5 over 6. Okay? This is going to give us what? 5 over 6. Right? 2 times 2, 4. 4 times 2. 4 times 2. Okay, I think we made a mistake. Okay? Yes. So let me wipe it off. Let's move. So it's like saying, let me open this. So we have 1 over 1 minus 2 times 2 is 4. 4 times 2 is what? 8. So it's 1 over 8. Alright? It's 1 over 8. Yes. Look at that question. So it's 1 over 8. And looking for the LCM is 8. And 8 divided by 1 is what? 8. And 8 times 1 is 1. Then 8 divided by 1 is 1. 1 times 1 is what? 1. And we have it to be 7 over 8. And this is your final answer. You have gotten what? The function of the material that have decayed. And option C is correct. So we have solved up to 5 questions. Remaining how many questions now? 5. Alright? So let's wipe up the board to have enough space to solve. So we have solved question 1 to 5, and let's let's continue from where we stop. Okay, now question 6 will appear on your screen. An ancient wooden artifact is found to have 1/8 the amount of carbon 14 as a fresh sample of wood. The half-life of carbon 14 is 5,730 years. Then you are being asked to get what is the age of the artifact. Now let's solve. Pay maximum attention because we are gradually doing what? Increasing. Okay, so this question 6. So which formula are we going to be using? We are going to be making use of this formula. Okay, where we have that n is equal to n original, right? Then we now have into bracket 1 then n. Now remember, in this question they said that an ancient wooden aircraft is found to have 1/8 amount as a fresh. So that 1/8 is our half. We need to convert it to a half-life. So now you need to apply the sense of indices here. Okay, so 1/8, this is 1/8. 1/8 is like saying, understand something. Okay, 1/8 is like saying 1/2 raised to power 3. I hope you know. It's like say 1/2 raised to power what? 3. So from here, since it is raised to power, we have already gotten our half-life. Okay, yes, because 2 times 2 is 4, 4 times 2 is what? 8. So our n is now going to be what? 3 times what? 5, 7, 30. 5, 7, 30 years. And anything that you have is your final answer. Okay, let's multiply. So we have that 3 times 5, 7, 30. So we have it to be what? 17,190. And this is your final answer. I hope you understand. I hope you understand what we did here. So you have to apply the sense of what? Of indices here. Okay, because we have been asked in the question to get what is the age of the artifact. Okay, we have been asked to get what? The age, which is the final. Okay, that is what we did here. Because our initial was what? Our initial was this. All right, our initial was this, and our time was 1/8. It was 1/8. Now let me show you something. So it's like saying, okay, 1/2. I'll still wipe this off. Okay, no, let me use here. 1/2 is like saying 1/2 into brackets raised to power 1/8, and I want to deduce this. I can simply say is what? 1/2 brackets 1/2 raised to power 3. So what is common here? This. So this will be out. So it's like saying that in log indices, when we have this, okay, and we have is equal to y, a is raised to power y. So what are we going to do? We bring down the what? Y. This is the law of indices. This is what I did here. I hope you understand. So now let's move on into question 7. Okay, now question 7 says in 180 minutes the activity of a certain radioactive substance falls from 1/8 of its original value. Calculate its half. We have been asked to calculate its half, which is its half-life. So what formula are we going to be using? We are going to be making use of what? Where's that formula? We are going to be making use of this formula. Okay, we are going to be making use of this formula. Now let's solve together. So we have n. Our n here is what? They say is 1/8. So 1/8 is now equal to what? 1/2 into brackets. Then our time here is what? Because our time is like saying our time is 180 divided by t. Okay, we are looking for this. Let's read the question. We have been asked to calculate its half, and it falls to 1/8 of each original value. 1/8 of its original value. Now let's solve together. Okay, let's solve together. So first thing that we are going to do is to deduce this guy. So deducing this guy is like saying bracket 1/2 raised to power 3 is now equal to bracket 1/2 raised to power 180 over t. So what is common here? 1/2. Okay, so we now bring down that 3 is now equal to 180 over T. Now, making T the subject of formula is like saying 3T is equal to what? 180. And T is now equal to 180 divided by 3. And divide fast. So we have 180 divided by 3. We have it to be what? 60 minutes. Okay? 60 minutes. And option A is correct. Now let's solve question 8. I hope you understand what we are trying to say. Remember this law of indices. The same base. We will take one, collect the powers. Okay? So, let's move. So we have question 8, and if you appear on your screen, they said a radioactive element has a half-life of 4 days. The fraction that has decayed in 16 days is what? Fr is equal to, we are using this formula, 1 minus what? 1 minus this. This is the formula we are using, okay? Which is bracket 1 over 2. Then our n is going to be what? Our 16 days, which is going to be 16 divided by 4. Okay? So we have Fr is equal to 1 minus 1 over 2 raised to power 4. Because 16 divided by 4. 16 divided by 4 is, let me check, let me confirm. It's 4 now. Okay. So it's like saying we now have 1 minus 1 over 16. And me not to solve this again. I already know that I'm going to be getting 15 over 16. Okay? And this is my final answer. And option B is correct. So now question 9. Okay? Question 9. They said a radioactive substance has a half-life of 20 days. What is the fraction of its original radioactive nuclei will remain after 80 days? What fraction? The same formula. Okay? The same formula. Now I hope you can be able to solve question, because once I've solved up to 1 to 5 questions, you can be able to solve the remaining on your own. Where we have that Fr is equal to 1 over 2 into brackets is my marker n. Okay? So let's solve together. Okay? Let's solve. Now we have our Fr. Fr is now equal to 1 over 2 into brackets 80 divided by what? 20. So from here we now have that Fr. I hope you can see here. Fr is equal to 1 over 2 into bracket 4. And when you do this, you have 1 divided by 16. And this is your final answer. Okay? So we have solved 1 to 9 question, and let's solve the last question. Okay? Let's solve the last. Do I need to solve this last question as number 10? No, I will not solve it. I'll give it to you as an assignment. Okay? Yes. I want to fully know if you understand what we did here. The question will appear on your screen, and I'll also put it in the comment box. Do it. Drop your answer in the comment box. Okay? So I hope you enjoyed this video. So if you enjoyed this video, do well to do what? Like this video, share this video to your friends that is having issues on radioactivity, and drop a sweet comment. Okay? So I still remain Nobu, CEO and founder of Nobu Team. So see you in the next video. Bye.